The second lesson in kinematics is about distance, displacement, speed, and velocity. The guiding question for this lesson is as follows. To most people, speed and velocity mean the same thing. Do they mean the same thing in physics? We're actually going to start with distance and displacement. Here's a happy little bee, and he's going to fly over to that flower. And of course, he kind of buzzes around on his way there. And if we highlighted the path that the bee followed, in this case it's the green dashed line, we would know its distance. Right? The distance it traveled is represented by the length of that green dashed line. Another way we could represent how this bee traveled to the flower is by imagining an arrow that points from where the bee started directly to where the bee ended up. And this would be known as its displacement. Right? The length and direction of this arrow is the bee's displacement. And clearly, the distance and displacement are different. They have different magnitudes. The distance line is much longer than the displacement line. Let's define these. Distance is a scalar quantity, and it's the length of the path traveled by an object. The actual path traveled, that green line. Displacement, which is a vector quantity, is the length and direction of an arrow originating at the object's initial position and ending at the object's final position. In other words, it's how far an object is from where it started. Right? Directly in a straight line, how far is it from where it started? And of course, the direction is important. Let's take a look at a couple of examples. Let's say one day you take the train into Penn Station, and you walk 7 blocks uptown, and then you walk 2 blocks across town to Bryant Park, and then you walk 7 blocks downtown to Herald Square. And we want to know your distance and your displacement. Well, you walked 7 blocks, and then 2, which is 9, and then 7, which is 16. Your distance traveled is 16 city blocks. But for your displacement, remember, we care about how far you are from where you started, directly in a straight line, and of course the direction, because that's a vector. So at Herald Square, you are 2 blocks away from Penn Station. And this red arrow represents that. So your displacement would be 2 blocks, and of course you are, looking at the map, southeast of where you started. Your displacement would be 2 blocks southeast. Here's another example. This is the track at the high school. And let's say one day during PE, you have to run a lap. And you start at this yellow X, and you follow the blue path around the track, and you end up back at the yellow X. Again, we want to know the distance and displacement. So I hope you know this. You've run around the track before. The distance around the track is a quarter mile, or in metric units, it's 400 meters. So your distance is 400 meters. That's how far your legs actually carried you. But your displacement is very different. You started at the yellow X, and you're ending up at the yellow X. So how far are you from where you started? I mean, you are where you started. You are 0 meters from where you started. There isn't any arrow that you could draw between those 2 points because they overlap. So in this case, your displacement would be 0. And I think this brings up the point about, in real life at least, what's more important, distance or displacement? And I think in this case, distance more accurately represents what you did. You ran 400 meters. But in physics, and also in real life sometimes, displacement is also a very important number. And we'll discuss that more in class. Right. On to speed and velocity, and this one's a little bit simpler. The velocity of an object, which is a vector quantity, is the rate of change of position. So it's how quickly an object moves from one place to another. And for this car, we know it's moving 90 kilometers per hour, and it's heading toward the east. So we would say that its velocity is 90 kilometers per hour east. It's a vector quantity, so it has magnitude, 90 kilometers per hour, and direction, east. Okay? Speed is a scalar quantity, and it's just the magnitude of the object's velocity. So we don't care that it's traveling east. All we care about is how fast it's moving, and its speed is 90 kilometers per hour. And that's basically it. To summarize this lesson, distance is a scalar quantity, which is the length of the path traveled by an object. Displacement's a vector quantity, and it's the length and direction of an arrow originating at an object's initial position and ending at the object's final position. And remember, in other words, this means how far the object is from where it started. Velocity is a vector quantity. Notice the V's, and it's the rate of change of position. And speed is a scalar quantity. Notice the S's, and it's just the magnitude of the object's velocity.